concept of abstract class and interface. Interface is called pure abstract class. It just tells you what to do and not how to do. Interface is just the collection of signature of methods. And like class, you extend class and you have to implement interface. We have seen yesterday what is an interface. The interface, using this keyword interface, we can fully abstract a class from its implementation. It tells you what a class should do and not how to do it. And it is to be with the subclass who is going to implement interface. To implement all the methods, it is compulsory to implement all the methods mentioned in the interface. So it is also called one interface, multiple methods. It is pure polymorphism, full form of polymorphism. It support dynamic method resolution at runtime. That means if whenever a object calls a method from a class, you create an object and using object you call the method. So the base class from where the you're calling that method and the class which has that particular method, both the classes should be present in the main memory at runtime, and their signature should match. So this should get resolved at runtime. And if you didn't want to load all the classes at compile time, then the solution is interface. So we have seen what is the difference between interface, abstract class and concrete class. Concrete class means our normal class. Abstract class means a class with at least one abstract method. It has normal methods, that is complete methods, as well as data variables. An interface is pure abstract class. It didn't have any concrete method. It just have abstract methods. It cannot have any instance variables, but it can have, interface can have variables which are final and static, and you have to provide its value. So we have seen this difference between interface, abstract class and concrete class. We have also seen that abstract class can have constructors. So we can define a constructor in abstract class even if we are not able to instantiate it. We are not able to create objects of an abstract class, but we can have constructors because child class constructor can call parent class constructor, and we can have instance variables in abstract class, and to define those variables constructor can be used by the subclass. It is also mainly used for multiple inheritance. And the syntax of interface is a keyword. So you can give access specifier. Yesterday we have seen that interface should be used always with a public access specifier. Even all the methods which you defined in the interface must be public. It can also contains data members of primitive types, and only static and final implicit. It is not compulsory to write these keywords or modifier static and final. Automatically, whenever you create any variable in the interface, it is considered as static and final. Even if you define a method, it is considered as abstract method. No need to write abstract keyword specially for interface. It is compulsory to write abstract keyword for method in case of abstract class. This is what we have seen in previous lecture. Let's start implementing interfaces. So once interface is defined, one or more class can implement that interface. So you can define an interface, and that is what you have done. Means you have created an interface, you have listed the methods in that interface. So the class, suppose you have class A and want to implement interface I. So when you say class A implements I, so class A promise to implement all the methods which are listed in interface I. And you can have multiple classes, like class B implements I, class C implements I. So each class can have its own version of its implementation. So it uses implements clause. In case of class, when you use inheritance, so class A extends B, where B is a class. And when you say class A implements I is an interface. So these are two, what we can say, clauses: implements clause and extends clause. So implements code in a class definition, then create methods required by the interface. This is a general form to implement interface. Class name, extend superclass, it can have extend superclass if any, and then implements interface, and it can implement multiple interfaces, interface 1 comma 2 comma 3 etc., and it can have class body. So if a class implements one or more interface, the interfaces are separated with comma. No need to write implements again. For example, we can write class A implements I1 comma I2 comma I3, where I1 is one interface, I2 is another interface, I3 is third interface, like this. If a class implements two interfaces that declare the same method, so now this can create an ambiguity. Yesterday we have seen what is ambiguity and why Java doesn't support multiple inheritance for concrete classes, because of ambiguity. If the same method is defined in both the parents, then which method to be called from child class? Here compiler can get confused, and that is called ambiguity. So same thing can happen with interface 2. A class which implements two interfaces, for example I1 and I2, and I1, suppose I1 has one method, and I2 also has the same method, then which method should be used by the client? That is the ambiguity. Then the same method will be used by the client of either interface. So it can choose, because all these definitions must be same, and the client should implement that method. That is the main requirement. So compiler will get that method in the client class itself. So no need to search in which interface it is defined, because it just contains a definition, or just contains the signature, not the body of a method. The method that implement an interface must be declared public. Okay, so we declare yeah, interface methods as public even if we implement that method in a class. That means suppose class A implements I1, I1 has method of A or method 1, and here in class A you are implementing method 1. So that method must be public. The type signature of the implementing method must match exactly the type signature specified in the interface definition. That's why the methods should be exactly same. Return type, method name, number of parameters, type of parameters, and sequence of arguments must match. So this is how we can define an interface. Interface should be public. Then interface is a keyword or a reserve word, and this is name of your interface. For example, doable. And here we have listed few methods without parameter, methods with parameter, but we didn't have any variables defined here, and we are not using abstract keyword, but these methods body is not provided. So these are all abstract methods. So we have four methods: do this, do that, do this too, and do that, do the other. So this is returning boolean, integer, void. So none of the method in the interface are given definition or body. And you are giving semicolon immediately followed each method header. So this is how we can define an interface. So our interface name is doable. It has method do this, do that too, do this too, and do the other. And we have a class, say public class can do, implements doable. So implements is a reserve word. So whenever any class want to implement these methods, so it has to write implements, and this will promise that all the methods which are mentioned in doable interface, these four methods, so this class can do has to provide method body for all those four methods. So each method listed in doable is given a definition by this class. This is pure abstraction. None of the method is defined here. Only definition signature is given. So you have to use exactly same signature, return type, method name, parameters, and type of parameters. So we'll try this one. Is it visible? So we have interface callback. Let's make this interface public. public interface callback. We have a method void callback. Only one method defined in this interface, void callback. Then we have a class client which implements callback, and this has to provide this method callback. And in any class which has main function, we can create object of client class. Client C1 is equal to new client, and we can say C1 dot callback. Okay. It requires one parameter. So note that exactly this definition should match void, void, callback, callback, integer, integer, and we are calling this. If you didn't write void, let's see what will happen. Class callback is public, should be declared file name as callback.java. Okay, this is in the same package. We should have only one public class in one package. That's why don't need to write public interface. Here it should be public. You can see now it is working. There is no error. Just close this error window. Uh, Program is started its execution from main. Object for client is getting created. Now client implements callback. So it will go to callback and check what are the different methods, and that methods you have to provide body for those methods. So C1 dot callback, you can see this callback function from client class getting called, and you have provided value 10, so it will print callback called 10. So these are only the method definitions which are available in an interface, and it is a promise whenever any class implement that particular interface, it is a promise that it will implement all the methods which are listed in that interface. So if you have another class callback, it can have other methods too, non-callback or non-interface methods. For example, this client class has implemented callback method, which is defined in this interface, but it can have another method, its own methods, which are not the method from interface. It is a normal class or concrete class. It has other methods too. For example, non-interface method. And here from the object of C1, using this object of client class, we can call this method non-interface method. So non-interface method means a method face which is not listed in the interface. It can have, the class can have its own methods. So it is calling callback method. Object is created client C1, client instance, then C1 dot callback. So callback method from client class is getting executed. You'll get the output. You'll come back to the main. And here in main, it will call non-interface method. So this method is getting called, and class that implement interface may also define other members too. So it can implement all the methods from interface as well as its own methods. That's why I shown you this one. So we have seen how to create an interface, how to implement an interface with a single method. Same thing we can do for multiple interfaces and multiple methods. A class that implements an interface can implement other methods as well. Just now we have seen. A class can implement multiple interfaces. We can have multiple interfaces, like here we have interface doable. So we can have another interface to client implements doable, comma, and we can have other interfaces too. The interfaces are listed in the implements clause, separated by commas. The class must implement all the methods in all interfaces listed in the header. So this is how we can implement multiple inheritance in Java. So we have a base class and we can have interface 1, interface 2 up to interface n. So abstract class or concrete base class. So class can extend a class and implement interface. And you can access, similar to abstract class, you can create object of base class and access methods from derived class. Same thing you can do with the interface. You can create reference of interface and call methods of the child class which implements that particular interface. So you can declare variable as object reference that use an interface rather than a class type. So any instance of any class that implements the declared interface can be referred by such variable. You cannot create object, you cannot create instance, but you can create a reference variable which holds the address of another object. And you can call methods which are defined in that object using this reference. So when you call a method through one
Excuse me,
object,
ma'am.
yes,
Ma'am, can you just show the previous example
code,
in
code.
no, in that Python
Okay,
something
okay.
where you compute those
Huh.
program.
So
Yeah, yeah. Ma'am, so here can we say that interface callback is our parent class and
yes.
like and class client implements callback is like it's the subclass and it is inheriting the
Huh.
callback. So then why do we have to do this? Means what's the difference between the inheritance and this interface?
So in case of inheritance, you have to provide body of that method and you are overriding that method. Means you are providing new definition for existing definition. But in some cases, it is not possible to provide definition in base class. Like in case of figure, we cannot calculate area of figure without knowing what that figure is. Or in case of shape class,
Yes.
there is no meaning for providing body for that particular method. It depends upon the client, or it depends upon the subclass who is implementing that particular interface or extending that particular class, has to provide or implement that method in their own way, can provide a body. But what we are restricting is, we want the method name should be like this, we want number of parameters should be like this, and we want return type should be like this. So that is the restriction. We have to impose that restriction to the user. User should use draw function for any geometric shape. uh, Dot draw function, either you create object of triangle class, rectangle class, or any other object, but that draw method should have these number of parameters. Should be the return type, this should be the name. So that's why interface is there. Interface will give you what the how your function should look like, and it you have to provide its implementation details in your class. So for example, here in client, it is using this method, providing this body. Another class will implement in other way. So there are
Okay,
different,
ma'am. Okay.
we can have concrete class here, we can have abstract class here, or we can have interface here. So client class can extend normal class, can extend abstract class, or can implement an interface. So this is the another way of inheritance. But here
Okay.
we
So
discuss,
there are no such restrictions for interference, right? Interface, right?
We can have multiple
Means as
interfaces.
in,
For example, here we have one interface. We can have another interface too. So it is mainly used for multiple inheritance. So I can create one more interface here. So this implements callback, comma, call me. What here, a single child, and we can have multiple parents. This we can implement multiple interface with this. So we can provide a
okay, ma'am. Yes. Yes, ma'am. Now I got it. Thank you.
okay. Just me check. So from this C1, we can call a method from another interface. Client implements callback, call me. We have public callback.
And ma'am, in case of inheritance, we can't have one subclass and two parent classes, right? Like
Yes.
here we separated the interface through comma, so it is not possible in inheritance.
No, no, it is not possible with extends keyword. You cannot write class A extends B, comma C. But you can write
Oh, okay,
extends
yes,
A
yes.
implements B, extends A implements B, comma C.
Okay, so we can include parent class and interface, but not
Huh,
both the parent classes. Okay,
yes.
okay, ma'am.
So
Thank you.
here my spelling was wrong. So it was giving me an error. The class should, it is not an abstract class. Then it has to implement methods which are declared in this call me interface. So call me interface just has one method. So I have to provide body of this method in my class. Whenever I say implements call me or implements callback, all the methods which are listed here need to be implemented, or you have to provide body for those methods here. Otherwise you have to declare this class as abstract class, and the another class who is going to implement this has to implement those methods. So this is how we are implementing multiple inheritance. We have a class, base class, which extends concrete class or abstract class and implements interface 1, interface 2, interface n, etc. So let me give you one more concrete example. In previous example, for abstract class, we have seen the figure class, which was abstract class. So we had a class figure. Now here I am creating interface figure. Interface figure. And let me define the methods like area. And we can have method like draw. I have a class, say, rectangle, which implements this interface figure. Now in rectangle class, we have variables like integer, length, and width, height and width, or length and width, height and length, okay. And we have accept function, or we can declare a constructor. and we'll initialize these variables. Length is equal to a, height is equal to b. And if we didn't provide these uh, functions or body for these functions, we will get an error in main. Here I'm creating object of rectangle class, 10, 20. If I try to execute this code, we will get an error. Rectangle is not an abstract class, so it has to provide method area as well as draw. Rectangle is not an abstract class, does not override method draw in the figure. So whenever we say implements figure, it has to override these methods. It is must. So let's override area method, void area. Here we'll print system.out.println area of rectangle is height into, sorry, length into height. This is area function, and same way I have to provide this draw function. The draw function will draw rectangle of that particular height and width. So here we didn't have draw option, means we are not implementing graphics. So let's display a message. Rectangle is of size, height is by this. Length by height. So in case in figure class, we just have draw method. It has not said how you can draw it. It is depending upon a class who is implementing this particular method can draw in whatever you can write here. Doesn't matter. It doesn't means compiler does not have any conditions what you write here. It has conditions on this. You should have this method definition exactly same as this interface definition. So these methods must be public. Whenever you implement a method from an interface, note that you have to declare it as public. And using class R1, we have to call R1.area and R1.draw. You can call these methods from main. So it is implementing this rectangle object is getting created with values A, B, formal parameters, H and L, actual parameters. So this is object R1. So R1 object is created with length 10 and height 20. And you are calling area. Area function is called from rectangle class. Compiler already matched its definition and you are getting rectangle and draw function executed like this. So if I have another interface, say fill, I have to check whether that figure is filled or not. So let's return boolean instead of void. Boolean field, it will return true or false. And I have a method fill with some color. so that it will fill that particular method with particular color. So let's accept color from the user. This is what I have defined that interface. Whenever you want to fill any object, you have to check whether it is filled. If yes, you can override that color. If no, you can ask user to enter a color to fill that particular figure, and you can fill it with the color. And color you can accept in string object. So if your rectangle class want to implement fill, just put comma here and fill, and then you have to provide body for these methods. So here in this class rectangle, you need to provide these methods public, not public, yes, public boolean filled. Here you'll check whether the triangle, the figure is completed or rectangle is filled with any color or it is not, no fill. So you can return true or false. So in this class, you can have that boolean variable, and you can check whether it is filled or not. You can initialize this boolean variable with some value from the default value from the user, and you can assign that value to this variable. And you can check if f is equal to true, return true, else return false. It will just check whether the figure is filled or not. This is a boolean function. Another function is fill with a particular color. So public void fill color and string variable, say s1. You can just print something in actual way. You can, if you are using graphics functions, you can fill that particular rectangle with a color. Rectangle is filled with, you can say s1, and you have to accept s1 from user, or you can pass s1 to that particular function. So note that we have to implement all the methods which are listed in figure interface. We have to implement all the methods which are listed in fill interface. And using rectangle object, you can call these methods. You can check whether it is filled or not. You can print it system.out.println. The figure is filled, and it will return true or false. It will print r1.filled will print true if it returns true, otherwise it will false. And next is r1.fill color. And let's say blue. I want to fill color figure with blue color. Sorry. So for any figure, if I take another class instead of triangle, if I create another class triangle, and triangle can implement area function. Okay. Here I have to pass true or false. So initially this is false. Error should be there. With errors you will learn. So now object is getting created. We have passed three parameters, A, B and C. C is for checking whether it is filled or not. So we have initialized this to false. So this is our rectangle. Height is 20, length is 10, and it is false, means not filled yet. So we have calculated area. Then we have drawn that rectangle of particular area 10 by 20. Then we have checked whether it is filled or not. So it has written false. It will print that particular value here. After execution, the figure is filled, false, not filled. So now we are going to fill it with blue color. So we have seen the string rectangle is filled with S1, filled with blue. Okay. So here, this is how we can implement multiple interface. A class can implement more than one interfaces. So, similarly, you can create a class triangle and try to implement these interfaces, calculate area, draw the triangle, check whether it is filled, or you can use filled it with gradient instead of color. So, or texture, you can do that. What I was trying to explain you that you can create reference of this interface. Now here we have created object R1, but I can create reference for interface. Similarly, how we create objects. Interface, what is the name of our interface? Fill, figure. So I'm creating object of interface. No need to write interface keyword, figure F1. So what is F1? F1 is reference for figure. And I'm passing F1 equal to R1. So now F1 is pointing to object R1. And using F1, I can call these methods, draw and area. But note that I cannot call these two methods with F1 because in F1 is a reference of figure interface, and figure just have these two methods, area and draw, which are common between figure and rectangle. But these two methods, fill color and filled, these two methods belongs to another interface, that is fill. So figure interface cannot call these two methods. If you try to call these two methods, it will show an error. So cannot find a symbol, method field. It is not available in the scope of F1. So you need another uh, reference F2, which is a type fill. And here F2 is also equal to R1. F2 is pointing to same rectangle object. And these two methods you can call with F2 instead of F1. So you can create a reference of interface to call methods of a class, which that class has implemented. Now why to do this? Just to hide implementation, make your program more secure. To implement abstraction, you can call that method with the normal object, but if you create an reference and then call, it will make your program more robust. So you can see here, we have references F1 and F2 and object R1. So first object R1 is getting created. Object R1 is there with height, width and field value false. Now we have created a reference. F1 is of figure interface, which is pointing to this R1. And now we have created another reference of field interface F2. It is also pointing to R1. But it is pointing to data, but not pointing to the method. F1 will point to the methods in R1, which are implemented from this interface F1. F2 will point to the methods in R1, which are implemented from interface F2. So you'll get the same output, nothing a difference one, but the calling is different. Instead of calling it with an object, we are calling it with the reference. F1 cannot call methods of fill interface. Fill interface reference cannot call methods of figure interface. But rectangle object can call all these methods. Is it clear? It's difficult to understand, but if you do it by your own, then it will be easy. So I'll share the link for this code, and I want you should add another class, say rectangle. Instead of a rectangle, you can add triangle class or circle class or any figure of your choice, and implement those interfaces and check. Or you can create another class. What is the next to the rectangle? If you want to create a cube class, cube, you want to add third dimension, height, width, and breadth. A cube, and instead of area you have to calculate volume. So what you have to do is class cube extends rectangle, implements figure comma fill. So I want you should try that one. Create class cube which extends rectangle and implements figure and fill, and check how it works. So I'll copy this class and put it in our Moodle link. I'll create a Moodle link here. So you can play with this. You can see this link here. If you click on this link, you'll get this URL. Click on this URL and you can see the code. You can copy this code, you can edit this code, you can modify this code. Okay. So this is called polymorphism. An interface name, that is figure F1 or fill F2, can be used as type of an object reference variable. For example, you can create doable was our interface. In this example, we have created interface doable. This is our interface doable. So we have created object, or what we can say reference of doable interface, doable obj. So we are using interface name and we are creating an object reference variable. Obj reference can be used to point to any object of any class that implements doable interface. So if you have class A which implements doable, so you can uh, create object of class A and assign it to obj. And from obj, you can call methods from doable interface. Do this, do that, do this, do, etc. So the version of do this that is following the line invokes depending upon the object obj is referring to. So you can just write obj.do this. So if obj is pointing to a object, then it will call do this for a class. If obj is pointing to b object, it will call do this for b class. Like in our figure, this program, in this code, if you have a class rectangle and rectangle, sorry, triangle should also implement area and draw. And if you are assigning f1 dot t1 is object of triangle class, and you are calling f1 dot area, so which area it should call from for triangle or rectangle is depending upon this assignment, which object it is pointing. F1 is pointing to now rectangle interface instance, so it will call area method for rectangle class. If f1 is pointing to triangle object, so it will call area method for triangle class. So as a user or as a third person, when you look here, you can just say that, oh, f1 is calling area function. So what is area function in f1? You check, area function in f1 is not implemented, but it is implemented by the class, and it is the class which is assigned, the object of that class is assigned to particular interface. For example, rectangle class is assigned to f1. So in this rectangle class, you have implemented area method. So area method for rectangle, triangle, circle can be different versions, and depending upon which object you assign to that particular reference, the method gets called. So this is a polymorphism. So the object can be used to point to any, sorry, obj reference can be used to point any object of any class that implements doable interface. The version, this line is very important, the version do this. So we have different versions of do this depending upon the class who is implementing this doable interface. Class A implements doable, class B implements doable, class C implements doable. So class A has its own do this method, class B has its own do this method, class C also has its own do this method. And you create the object, you assign it to obj, which is a reference of interface, and obj.doThis will call the method for a particular object. So the following line, that is this line, invokes means calls depending upon the type of object obj is referring to. I hope this is clear. The reference is polymorphic, which can be defined as having many forms. So depending upon which object we assigned, that particular method gets called. That line of the code might execute different methods at different times if the object that obj points is changed. For example, in previous lectures, I shown you a for loop. For obj of I dot do this, suppose, and for every I we have assigned different objects. Obj of 0 is pointing to rectangle, obj of 1 is pointing to triangle, obj of 2 is pointing to circle. So if value of I changed, then the particular object assignment is changed and different methods gets called. So even if that line is on that particular line number, so it executes different functions at runtime. So this is polymorphism. Note that polymorphic references must resolve at runtime, because at compile time, when compiler look to your code statically, it looks exactly same. Means it cannot resolve which method it is going to call. So this is called dynamic binding, and we have to use these references very carefully. So careful use of polymorphic references can lead to elegant, robust software design. Why to do this? We can't it straightforward, we cannot create the objects of class and call all the methods of that particular class. Yes, we can, and that too will get the same output. Then why to go with inheritance, why to go with interfaces, why to go with abstract class? To make our code more elegant, more robust, for software design, and more professional code you can write with the help of polymorphism. We'll see this example in the next lecture. We'll stop here. Any queries about interface, how to implement it, and how to use the interface reference to call class methods?